Welcome to episode 23 of Ask the Grounding Experts, where our experts from ENS Grounding Solutions answer your engineering questions about the world of grounding and earthing. Today, the legendary David Stockin answers the question, how can step voltage accidents be prevented? Because these can be extremely dangerous, if not deadly. Save us from ourselves, David.
Okay, so today's episode, we've had some questions about some of the incidences we've seen in the news about step voltages that people unfortunately have been killed. And obviously it's hard to comment on issues that we haven't investigated or been part of. So, and obviously our hearts go out to the families of people who have been injured and electrocuted. Recently, there was one in the news about someone being electrocuted from 42 feet away through step voltages, and a lot of folks had some questions that, is that really possible? And the answer is it certainly is. So when we deal with soil resistivities, you can imagine, we talk about them in cubic meters. So take a 1 meter by 1 meter by 1 meter block, of soil, and you pull it up and you put steel plate, plates around on the edges, then measure the resistance across it. And when you start dealing with wet clays, for example, you can be only a few ohms across this cubic meter worth of soil. So imagine it's a little wet outside. You've got this layer of clay that's only a few inches thick, but it's wet and highly conductive, and you get accidental contact to an overhead voltage line. Electricity comes down the truck, probably blew the tires out, hits the ground, or maybe they had the stabilizers down, goes through the stabilizers, hits that clay, and it can travel very, very far. You're only talking about a few ohms of resistance, and it hits somebody, gets up into their feet, maybe they have a difference in potential, and all of a sudden you have a major, major problem. Going back to, we've talked about this before, lightning strikes the field. Half the cows in the field die, right? So it's an open field, cows are grazing along, and lightning comes along and hits the center of the field. It hits that field, those electrons, they're just looking for an orbit to get back onto around an atom, and they go to the first atom and they tie up. When that one's full, they got to go to the next one. They keep looking. So as that electricity enters the earth, it's like dropping a pebble into water. It sends this wave or ripple across the surface of the earth. And if we had a voltmeter, the closer we got to the lightning strike, the higher the voltage would be, and the further away. So the cows facing the lightning strike, if the front hoof is at 750 volts and their back hoof is at 1,000 volts, that's a 250 volt differential, and it can kill the cow. If the cow is standing perpendicular to the line, so then the front hoof's at 1,000 volts, the back hoof's at 1,000 volts, that's a 0 volt differential. The cow lives, no problem. If, unbeknownst to the cow, we had buried a ground ring down below its feet and below grade, completely circumnavigating that cow, that wave of it, or ripple of electricity, would have come along, hit the copper wire, gone around the copper wire, charging it evenly, and carried on its merry way, and the cow could have stayed anywhere in the position it wanted to. This is one of the powers of ground rings and how important they are, and this is why we put ground loops around buildings and substations, transformers, all these things that balances the voltage differentials, and the voltage differentials kill you, not the voltage, right? So like the bird on the wire, right? The bird can be up on top of the high voltage line, no problem. It's if the bird touches something else at the same time, it kills the bird. You could do it too, although I highly recommend you don't give it a try. But yes, so it's those voltage differentials that kill you, and that's what happens here. Is you get electricity entering the earth, whether that's from a lightning strike or another power line and it goes across the surface of the earth. And if you're standing in the way, that's called step voltages. It's a known phenomena. We have standards and codes. IEEE Standard 80 discusses it extensively. Even OSHA recognizes it. In 29 CFR 1910.269 Appendix C, they talk about the known risks of step and touch voltages. How can you mitigate them? It can be difficult, particularly in temporary scenarios. Even if you had the truck properly grounded in those wet environments, or where you have highly conductive areas like that, it can be very dangerous. The best thing you can do if you're in an electrical worker, make sure you're wearing electrical hazard safety shoes. They carry millions of ohms worth of resistance between your feet and the ground, and that can help save your life. If you're kneeling on the ground, that's a problem, obviously. Rubber mats and things that obviously, for anybody with a high boom truck, you got to look for those power lines, obviously. We all know this. We won't get into preaching that, but step voltages can travel. They can travel far further than 42 feet. They can travel thousands of feet. We've seen this with lightning strikes and cows in the field. Thousands of feet away, cows can be killed from this. And it can, if it gets up onto a metal fence, all of a sudden it converts to touch voltages, and it can travel even thousands of feet further down there, doing touch voltage damage, which is even worse than step voltages. You are far more susceptible to those. So it's unfortunate. People do die from these events and these scenarios. It's very important that you plan accordingly and consider these issues, particularly when you're dealing with anything over 1,000 volts. You definitely, by code now in the NEC, in Article 250.191 and 194, anything over 1,000 volts, you must take into consideration the step and touch voltages in accordance with IEEE Standard 80. If you have any questions on that, obviously we'll be here to help you out. We're going to keep this one short today. If you're listening to us on a podcast, feel free to hit that subscribe and give us a rating. If you're on YouTube, hit that like button. Leave us a comment. There's lots of information below for links and different things that you can find. Obviously, please visit our website. And if you feel like it, leave us a comment, send us an email, or give us a call. Thanks a lot. Have a good day.
Thanks so much for watching. If you found this episode helpful, please give us a quick like down below and subscribe to stay up to date on future educational videos we will be publishing. And feel free to post questions or comments below as well. We might even feature your questions in future videos. If you'd like to learn more about the amazing world of electrical engineering and grounding, be sure to check out our certified online courses at the links in the description below to kickstart your career. See you next time.